Okay, so today's video is about similar figures. Specifically, it's going to be about similar triangles. We have two EQs. What are the ways to prove triangles similar, and what are the results from similar triangles? So just a little bit of review. Similar figures, similar triangles. The similarity symbol is given to you here as a little squiggly mark, the tilde. They are the same shape, but not necessarily the same size. We have three ways to prove triangles similar: angle, angle, side, angle, side, and side, side, side. And if you're using the sides to prove that the triangles are similar, they have to have proportional sides. So we have corresponding angles are congruent and corresponding sides are proportional. So we're going to look at our two triangles here. We are given that they are similar in our statement here. And it is a similarity statement. It's just like a congruent statement. It's letting us know what is corresponding. So we're going to write which angles are congruent and which sides are proportional. So angle A is going to be congruent to angle T, which is shown in our picture using one arc. Angle B is congruent to angle S, and angle C is congruent to angle R. So now we're going to write the corresponding sides as a ratio using a fraction. So AB would correspond to TS, BC would correspond to SR, and AC would correspond to TR. So now that we know all the sides that correspond, we would be able to plug in our information and write a proportion and solve for any missing side, which is exactly what we're going to do right down here. So I know that MP corresponds to XZ, given to me in my similarity statement. And I know that PN corresponds to ZY. So now all I have to do is plug in the information that I have from my triangle into that proportion. So PM is X plus 5. XZ is 30, PN is 4X minus 10, and ZY is 75. So to solve this proportion, we're going to cross multiply. So I get 75 times X plus 5 equals 30 times 4X minus 10. Make sure you distribute the number to both parts in the parentheses. So I get 75x plus 75 times 5 is 375. And then distribute the 30. 30 times 4 is 120. And 30 times 10 is 300. So I'm going to switch my colors. I'm going to subtract 75x from both sides. And then I'm also going to move my 300 over. So I end up getting 675 is equal to 45x. And then I'm going to divide by 45 on both sides, and I end up getting x is 15. For the second problem down here, I'm going to change colors so we don't get our work mixed up. They're asking you to find AB, which is this piece right here, corresponding to this segment FE. So in this case, we could use the corresponding sides ED and BC, or we could use FD and AC. I'm going to use ED and BC just because the numbers are smaller. So I'm going to say 6 over 8 is equal to x over 20. So we're going to cross multiply. So I get 8x equals 6 times 20, which is 120. And I'm going to divide by 8 on both sides. So I get 120 divided by 8. So instead of doing the long division for that, I'm just going to simplify my fraction. So let's see, 60 and 4, 30 and 2. So half of 30 is 15. So for this one, x is also 15. It's kind of nice. So I'm going to work one more down here. We want to know the value of x that makes triangle ABC similar to DEF. So we're going to assume they're similar and then solve. So in this case, we have to use the corresponding sides AB and ED because those are the only numbers that they give us without variables. So 4 over 12 equals, and I'm going to use 8, the side AC, and then 3x, I'm going to go ahead and distribute. This is 3x plus 3. So now I'm going to cross multiply and solve. So I get 4 times 3x plus 3 equals 96. So I'm going to distribute my 4. That's 12x plus 12 equals 96. So subtract 12. That's going to be 84. Divide by 12. And you get x equals 7.